Welcome. In the last video, we had learned about the series unbiased clipper circuits. Now in this video, we will see the series clipper circuits in biased condition. Let us take an example. Here the diode is in series to the applied signal Vin, so this is a series clipper circuit, and since along with this input signal Vin there is an external voltage source of Vv present in the circuit, so this is a biased series clipper circuit. Suppose Vd is the voltage across the diode with this polarity. Now let us analyze the biasing condition for the circuit using KVL law in this mesh. So we have Vin minus Vd minus Vb equals to 0, that is Vd is equals to Vin minus Vb. Now for the forward biasing of the diode, the Vd must be greater than 0, because for that only the polarity will be same like this. So Vd should be greater than 0, that is Vin minus Vb must be greater than 0. That means Vin must be greater than Vb. So this is the condition for forward biasing. And for Vin less than Vb, it will be in reverse bias. Suppose Vb value is less than the maximum value of Vm. Now when the diode will be in forward bias, the equivalent circuit will be this, where this Vo will be equals to this Vin, and this is for Vin greater than Vb in the forward bias. And in reverse bias, the equivalent circuit will be this, where Vo will follow this Vb. So Vo is Vb, and this is for Vin less than Vb. Now let us see the output graph. This is our input signal. This is Vm, and suppose this value is for Vb. Now for Vin greater than Vb, the diode is in forward bias, and for that case Vo is following Vin, that is in this region the diode is in forward bias, and except that everywhere the diode is in reverse bias. So for this duration the output will follow the input, and except this duration in every cycle Vo will have a steady value of Vb. Suppose at this position Vb is situated, so our output graph will look like this. Now you can see that below this DC level the signal has been clipped, so this is a negative clipper circuit which is biased and series. Now let us see the transfer characteristics. Suppose this is the Vb. For Vin greater than Vb, that is this side, Vo is Vin, so we will have a ramp signal, and for Vin less than Vb, that is this side, Vo is Vb. So this is the transfer characteristics for this circuit. Now let us take another condition where the circuit is this. Again here we are taking Vin as Vm sin omega t. Now let us find the biasing conditions. So put KVL law in this mesh. Vin plus Vd minus Vb is 0, so Vd is Vb minus Vin. So for the diode to be in forward bias, the polarity should be same like this, and for that case Vd should be greater than 0, that is Vb minus Vin should be greater than 0, that means Vin must be less than Vb. So this is the condition for the forward biasing. Similarly for Vin greater than Vb, we will have reverse bias. Now when the diode is in forward bias, the equivalent circuit will be this. where VO will be V in. And for the reverse bias condition, the equivalent circuit is this. Now put KVL law in this mesh. VB minus VO is 0, that is VO will be VB. So let us see the output graph. This is our input VM, and suppose this is VB. We are taking VB again less than the maximum value VM. So for V in less than VB, the diode is in forward bias, that is in this duration the diode is in forward bias, and except that is in this duration the diode is in reverse bias. For this forward bias, the output will follow input, and for this region it will be VB. Now let us see the transfer characteristics also. This is VB. For V in greater than VB, that is this side, it is VB, and for V in less than VB, that is this side, it follows V in. So this is the transfer characteristics for this case. Using these concepts, try to solve these two circuits, find their biasing conditions, the output graphs, and the transfer characteristics. I hope it will be easy for you, but in case you have any problem or you have any doubt for the topic, then comment below and I will try to clear them. And in the next video, we will discuss about different types of parallel clipper circuits.